you for giving me this opportunity to present my thesis in this conference. Good morning, everyone. My name is Anshika Karn, and I'm going to present my dissertation titled Automation Possibilities of Requirements Checking for Digital Building Permits Issuing when Introducing IFC Standards. It is supervised by Professor Yerni and Professor Anka. So starting with building permitting, we all know that building permitting is a very important aspect in the construction of any new buildings. And it is undoubtedly one of the most complex and long process because in most of the places, it's still manual and analog, as we have already seen in previous presentations as well. So also, according digitalization has been making its way into all these sectors, and building permitting is no exception. And also, we are seeing, according to some of the studies, we are seeing a significant economic benefit when introducing digitalization and automation in their processes. And since compliance checking is the most important step in the building permitting, in my thesis, I have mostly focused on the automation of the compliance checking. So for this, I divided my work into 4 stages, which is investigation, framework development, application, and evaluation. So in the first stage of investigation, I mostly focused on the identification of problems in the existing processes and the availability of the available approaches done in past and recent years to cope those problems. So the problems that were mostly figured out is that every year, lots of applications, since AC is a growing industry, many applications are submitted every year. And due to the manual checking of the huge number of applications, it's rather time consuming and tedious. And also, since the process is mostly manual, it's sometimes incomplete and arbitrary and produce arbitrary results. And for this process, this is done with literature, the study of academic literature, and also I conducted some interviews with the industry professionals who are working in the building permitting processes. So these problems is a huge problem because it's a growing industry and to save time. But there are some notable works in the past, like we came across the study of coordinate, StatsBig, design check, and KVM codes. And along with that, there are also some European efforts which are going on in the digital building permitting process. So some of the notable works are EUNet, CheckDBP, DigiChecks. But even after studying all these efforts, one thing we noticed that most of the processes use extensive programming languages and are mostly dependent on some specific checking softwares like Solibri model checkers or similar to that. So a process that needs that is not dependent on any specific software and can be done with OpenBIM was a must. So my main focus was to develop a framework that use OpenBIM standards and is not limited to any specific software. For that, we can see in this IDF0 diagram, the as-is model shows the current input and the regulations that are going on for the compliance checking. And the aim is to replace the inputs to IFC model and the automated checking with IDS verifications and produce digital reports. So for that, the second stage was the framework development, where we designed a framework to automate this process and develop the framework. So the main focus was to convert the written textual regulations into machine readable formats and also find a way to extract the important information from the building model. For that, this is a detailed process of my framework that we developed in this process. So it's following the Eastman's rule processing. And the first step is a rule interpretation, which involves the translation of the written textual regulations from the legislation to machine readable codes called IDS files. So IDS files, IDS is a new standard by Building Smart, and IDS is an XML document, which I'm going to explain in the next slides. So for now, the first step is rule interpretation, where the careful analysis and classification with the careful classification and analysis of the rules and using Rasse markup technologies, the written text in the legislation are converted into IFC files. Then a next step, or it can be done simultaneously as well. It's called model preparation. So a raw BIM model from a raw BIM model is not used in the framework, because since this process is promoting interoperability, first standardized IFC files needs to be created, and that are done with using standard guidelines, LOD specifications, IFC based configurations, and even the input of some parameter mapping. And it can be done with any authoring tool. So for this framework, the rule interpretation and model preparation, these doesn't use any specific software, but can use any BIM authoring tool. And the third step is rule execution, where the standardized IFC files are checked against the created IDS files. And the last step is checking the report of the rule execution. So IDS files are basically XML documents, which can also be human readable and also machine readable. So in the human readable version of IDS files, we can easily create those files using facets. So facets are entities, properties, materials, etc. Those facets can be used to create specific data for the IC files, and the same for the IDS files, and the same IDS files can be read by the computers, because and the XML document of IFC files can be checked against the XML documents of the IDS files. So in a typical IDS workflow, IDS files are generally used as a way to exchange information requirements between the clients and the BIM modelers. So clients create the IDS files with their own project requirements, and those IDS files can be used as a way of requirements by the BIM modelers. And after the creation of the BIM model, the client can again check their files against the IDS files for the validation. So the stage 3 of this dissertation shows the application of this framework into an actual scenario, where in this application, I have applied this framework uh, in the scenario of my home country, Nepal. So for the text, for the rule translation, I selected the written architectural requirements document of Nepal NBC codes, and then classified the rules written from that document. And the standard IFC files were created by using the authoring tool Revit. And for the rule translation and rule execution, BIM Collab environment was used. So in a typical DBP workflow, according to this framework, the rule translation and rule execution are the responsibilities of the building permit authority, while the BIM model preparation is the responsibility of the applicants. So explaining further, the written regulations in the National Building Code were first classified into direct, indirect, subjective, and non-applicable. And 3 rules were selected from the direct categories, which were further divided into requirements and applicability using RASI markup language. And the requirements and after the extraction of requirements and applicability, those rules were converted into the IDS files using BIM Collab. These were the rules that I selected for the translation into IDS files. Then for the model preparation, standard guidelines were used. This is an existing residential building which is already built in Nepal. But since the building permitting process there doesn't use BIM model, I created this model according to LOD 300. And this design already adheres to the Nepal National Building Codes. So the IFC 4 was used, and for the property set, some custom base quantities and some custom properties were also incorporated while exporting the IFC files. For the rule execution phases, I intentionally put in some incorrect properties in the file to show how the tools respond to these failed elements. So in the first case, there were some incorrect properties in the elements, and it shows that the tool shows the failed elements visually in red color. And there are also some specific modes that we can use while viewing the failed elements. In case 2, there were some missing components, so it shows as no applicable components. And these case 1 and case 2 both are deemed as failures. In the case 3, all the properties were corrected and all the components were visible in the IFC, and that's when executing the rules, it shows as check pass. So these are the 3 cases which can be seen in the framework. And the last and final stage was evaluation phase, where the results from the execution were discussed, and also the limitations and scope for futures were discussed in this phase. So the key findings that we evaluated of the framework is that since the execution of rules were pretty fast, it's practical and efficient, and with some minor changes in the codes, it can be adapted to any places. Like I created the files for Nepal's codes. In the same way, we can change the some minor data in the IDS files, and it can be used to translate codes from any country's legislation. So it's quite adaptable. And since it's open beam standards, it's not limited to any specific software, and any authoring beam tool can be used. And the use of IFC formats, obviously, it makes the files lighter and accessible to computer. And the most important part is, since in this framework, the IDS files need to be pre-available to the applicants. So that way, the applicants can check their model before submitting them to the building permit process, which makes it easier to make necessary changes when it's still affordable and it's before application. So they can submit a already validated model, and the process will be faster. But like any framework, it has its own challenges and limitations. The most challenging thing I faced while doing this process was the transition of the conceptual methodology into the practical implementation. Because since there are lots of written regulations in the file, it's not that easy to convert those into the IDS files, because most of the rules are in ambiguous nature, and it's not easy to just divide it into those are mostly qualitative than quantitative, and it's not easy to divide it into um, it's not easy to divide it into requirements and applicabilities. That which requires a lot of human input here, makes it a hybrid nature, making it hybrid in nature. Then also, since even the processing time for rules is fast, processing all the rules at once might become slower. And since IDS is still a new standard, still developing, so it's limited to semantic checks, and conditional and calculational rules are not that possible right now. But in the future, but in the future, it's a good thing that the developers are working towards the upgrade of the standard. And in the future, it might incorporate some geometrical checks. And with the standardized modeling processes, the framework can be more efficient. And also the integration of AI can be used in the translation of the rules. And even also the integration of GIS might make the spatial planning checks possible. But the most important thing is to develop any framework which needs to be incorporated in the government system. There is the direct collaboration with the municipalities is a must, because to adapt this framework into the government process, it needs a joint effort from the technological and the administrative side. Thank you.